Today I'll be talking about Kilobeat, a platform for low-level collaborative live coding. So the scenario is a typical jam session. People get together to make some music, they're in the same room, they can see and hear each other, and they can move around. They can pick where they set up, where the sound is coming from. The twist is that everyone is playing the same instrument, the code box. And this is the scenario that Kilobeat is built to address. You want to make music with other people, but you might not be particularly close to them. There might not be low latency between you, but you still want to jam. So in Kilobeat, players make music by writing short code expressions, and unlike most live coding languages, these generate audio samples directly. Each player has their own code box for their expression, and because the code boxes are small and they're writing expressions rather than statements or blocks, players are encouraged to keep it simple and build complexity by working together. Players can see and copy each other's expressions, and they can also establish direct dependencies on each other's output, which I'll talk more about later. So in the remote music making space, there's some systems that transmit audio between players, like Jacktrip and Jamulus. These are great, but they're latency dependent. And then there's Ninjam, which adds artificial latency to reach a precise, musically meaningful delay. So it's heavily delayed, but it's at the right point in the form. In contrast, collaborative live coding systems usually do not send audio, they send text, code, player actions. So latency is not so critical because they're synchronized to a common time base. This category includes Troop, Estuary, and Quaver series, and it also includes Kilobeat. Kilobeat also falls into the related category of JavaScript-based music programming systems. So Jibber and Jazzari are live coding systems in JavaScript, and EarSketch is an educational system that supports JavaScript and Python. Kilobeat is heavily inspired by the practices of Bytebeat, in which you make music with short, terse programs, generating audio at the sample level. Traditionally, these are in C and involve a lot of bit manipulation, so left and right shift, bitwise, OR, and XOR. Kilobeat is inspired by this, but it has somewhat different goals. So it uses floating point samples and a high sample rate compared to Bytebeat. It exposes common math functions like sine, and the goal is to get to a more familiar notation as you might find in a DSP textbook. So something like sine of 2 pi ft describes a pure tone at f hertz if t's in seconds, and in Kilobeat that maps directly to sine of 2 times pi times f times t. And with that, here's a short demo of Kilobeat in action. Welcome back. As you probably saw in the demo, players write expressions in JavaScript to make music in Kilobeat, and some JavaScript features like the arrow syntax for anonymous functions did come into play in that demo. These expressions generate one sample at a time, so players can work with pitches, notes, and rhythms, but they can also work at a lower level to describe filters, effects, and envelopes directly within Kilobeat. Kilobeat includes a few augmentations to standard JavaScript. So for instance, you can say sign instead of math.sign, and you can use a phase accumulating variant for things like FM synthesis. Kilobeat exposes variables like t for the current time in seconds, as well as variables like x, which the player can use however they like. Players can also use variables to establish dependencies. So if a player uses the variable p0, that will refer to player 0's output 128 samples in the past. And players can build up webs of synthesis this way. So this is the Kilobeat client. The server, which is written in Python, supports real-time collaboration, so you can see each player's cursor, you can see their edits, sort of Google Docs style in real time, and you can also see their position. So each player can move around and have their sound come from wherever they like in this virtual room using the head-related transfer function for spatialization. Kilobeat also provides immediate audio-visual feedback. So as soon as you hit run, you'll hear the new code's output, and you'll see it via oscilloscope and spectrum analyzer. Kilobeat also provides presets, which provide code snippets for common synthesis techniques, and it provides replays. So you can record player actions, and that includes cursor movements, speaker movements, as well as code, and you can play it back. And one interesting point here is that these are aleatoric. So if a player uses randomness in their expression, then that randomness will get re-executed on playback and might have a different outcome the next time. The web audio graph looks something like this, where each player has an audio worklet for their expression. It goes to an analyzer for the spectrum display, and it goes to a panner for spatialization, which goes to the output. But it also goes to a channel merger that feeds back into each audio worklet, so players can establish dependencies amongst themselves. In summary, Kilobeat's a collaborative live coding platform with some unusual features: audio generation at the sample level, spatialization for each player, dependencies between players, and action-based replays that are naturally aleatoric. It's available at ijc8.me/Kilobeat, and the source is on GitHub. Kilobeat is built on Arthur Cabot's Audio DSP Playground and Boris Smooth's Web Audio demos. Thanks to Family for playing, and thanks to Todd Mackover, Jason Freeman, and Ian Hatwick for feedback. And thank you for watching. Please come by the Kilobeat poster session, ask questions, and try it out. Thank you.